Alright, today we're going to talk about parabolas, which is our second conic section. Now, parabolas we studied a little bit in Module 4, but we're going to take a little more in depth at looking at parabolas and looking at a couple different types. Now, the way a parabola is officially defined is it is a set of points equal distance from a point and we call this point the focus and a line. And we call this line the directrix. So if we have a line that we fix in place and we have a line which we fit in place, all the points that are the same distance from these two are considered to be on the parabola. So I kind of made an example here. Here's a parabola, which we kind of know what it looks like. This one actually opens to the right instead of our traditional up and down. So we have this line. In this case, the line is a vertical line. And here is our point, which is a focus. So every point on the parabola, if I measure this distance from the point on the parabola to the focus, and measure the distance from the point to the directrix, these distances would be the same. So if I take another point, let's say I take this point up here, and I measure this distance here, and then I measure the distance to the directrix, these distances would be the same. So any point on this parabola would have to be the same distance from this focus and this directrix. Now there are two types of equations for parabolas. There's one equation that opens when the parabola opens left to right, something like this, either to the left or to the right. And there's one when the parabola opens up or down. Now the equation that we have for the one that opens left and right is 4ax equals y squared. And the big thing is what this a stands for. A is the distance from the vertex to the focus and the directrix. Remember from earlier, the vertex is the point at the bottom or the side of the parabola. And then we have this focus and this directrix, which it has to be the same distance. So A is the distance from the vertex to the focus and the directrix. So you'll notice that the big thing is the squares on the y. When we wanted to open up and down, you'll notice it's the same formula basically, except for the squares on the x, and then the y is over with the 4a. But A means the same thing. A is always going to be the distance from the vertex to the focus, and it's some number multiplied by 4 out in front of whatever the single linear variable is. Now another kind of neat thing with the parabolas is we have this segment which is called the Latus Rectum segment. So if I have a parabola, and let's say this parabola opens up and down in this case. Say it opens up. So my focus is somewhere in the middle. That's our fixed point. It's always inside the parabola. So our directrix would be back down here in this case. Well, what the latus rectum is, the latus rectum is a segment that goes through the focus to both sides of your parabola. So the longer your latus rectum is, the wider your parabola gets, and the shorter your latus rectum is, the narrower your parabola gets. And the neat thing about this latus rectum is the latus rectum length is always equal to 4a. Well, it's equal to the absolute value of 4a. It's always positive. So the length is always whatever that 4a chunk is in front of our parabola. That will always give you the length of your latus rectum segment, which basically tells how wide your parabola is going to be. So let's look at some examples. So we had those equations on the previous page that gave us the way to find a parabola equation if it had a vertex at the origin, which this one will, and whether it opened up, left, up or down, whatever it will be. So we want to find the equation of a parabola with a vertex at the origin and a focus of 9, 0. So if I make a little crude graph here, the vertex is at the origin, 0, 0. And the focus is at 9, 0, which is somewhere out in this direction. Now, since the focus has to be inside the parabola, we know the parabola opens to the right. Now, if we remember the equation for all parabolas that open to the right, that are centered at the origins, it's 4ax equals y squared. So we know the equation of this parabola is going to be 4ax equals y squared. All we have to do is figure out what a is. Now, a was the distance from the vertex to the focus. So how far is it from 0, 0 here to 9, 0? Well, that distance would be 9. So this a value would be 9. So we say 4 times 9, x equals y squared. So that would be 36x equals y squared. So this is the equation of a parabola that has a vertex at the origin and a focus at 9, 0. If I wanted to know how long the latus rectum was, the lattice would be the length of 4a, so the lattice length would be 36. It's always just this chunk out in front of x. So I went ahead and graphed this on Desmos just so we could kind of see what it looks like. So it's definitely opening to the right. You can see I put in 36x equals y squared. So there's our vertex. Our focus is somewhere out here at 9, 0. You really can't see where that be. But if I were to make this lattice segment, you see it goes up about 18 and down about 18. So that length would be 36. So this is a pretty wide parabola. Okay, this one says graph the parabola 16x equals y squared. Now, first of all, I know this opens to the right because it has a y squared. It's right or left, but because it's positive, it'll open to the right. So this will open right. We know it has a vertex at the origin because it's in that form. And now we just have to figure out how far is it from the vertex to the focus and the directrix. Now, this chunk here is 4a. So since 4a is 16, then 4 times what number is 16? A would have to be 4. So the distance from the vertex to the focus would be 4. So if I graph this, I have my vertex there, and I have a focus which would be 4 units away to the right. So if I go 4 units to the right, here is my focus point at 4, 0. So I have my vertex and my focus. My lattice length would be 16 because it's just that chunk in front. So if I wanted to get an accurate graph, and you can graph it on Desmos, but just know, since the lattice length is 18, I can just go up 8 units on top and 8 units on bottom, and I know that will get me to new points on the parabola. So this parabola would open something like this. So it opens to the right. We kind of plotted where the focus would be 4 units away. And using that lattice length, we were able to see how wide it is. And if I look at what the Desmos graph is, it seems pretty close to what we have. 4, 0 is here. And so you can see up 8 units and down 8 units. Seems to put us at 4, 8, and 4, negative 8. And if you look at our handmade graph up here, those endpoints of that lattice look to be 4, 8, negative 4, negative 8 as well. So both information on the handmade graph and our Desmos created graph seem to agree. Now, the only difference in our next couple problems is the ones we did earlier had a vertex at the origin. They don't always have to have vertex at the origin. They can have a vertex anywhere you want. But what we do is we just shift them basically with an h and a k. So if we have a vertex of h and k, you'll see how we changed the original equation. So it used to be 4ax equals y squared. Well, we simply subtract the h part of the vertex and subtract the k part of the vertex. So similar to a circle, whatever's in those parentheses, if you're pulling it out to get the vertex, you make it the opposite sign. And that's true no matter if it is for a y squared one where it opens left, right. So this one would definitely be one that either opens left or right, or one like this one where the square is on the x and it opens up down. So the opposite of these things will give us our vertex. Everything else will work very similarly. Okay. Let's look at this next example. So we have y minus 2 squared equals 4x plus 2. So first of all, let's think about which way it opens, left, right, or up, down. Now the square is on the y term, okay? So this is going to open either left or right, but the number's positive, so it's going to open to the right. So this parabola will look something like this. Now because it doesn't have the nice vertex, the vertex is not at the origin, let's think about what the vertex is. Now the vertex is just some point xy, and then like we said, it's the opposite of the things in this parenthesis. So I have x plus 2, so if I take the opposite of 2, if I pull it out, my x part will be negative 2. And if I look at the y part, it's y minus 2, so if I take the opposite of minus 2, I have 2. So my vertex will be negative 2, 2. So I know that's going to be here. That's my vertex, and then it's going to open somewhere to the right. Now the other thing I know is I know that this chunk in front of the x term is 4, and that's also 4a. So 4 times what number gives you 4? Well, a has to be 1. So that means the distance from the vertex, which is now negative 2, 2, to the focus is 1 unit. So I'm going to zoom in here. So I'm going to go just 1 unit to the right because the parabola opens to the right, and there's my focus. I know my Latus Rectum segment has a length of 4a. So in this case, 4a would just be 4. So the lattice length is going to be just 4. So if I want to graph it by hand, I know it goes through that focus. I could go 2 units up and 2 units down. And I could just simply connect those points. So it looks something like this. So the lattice was much smaller than our other one. Our other Latus Rectum was like 36. This one's only 4. So it's a much narrower parabola. So not the greatest drawing, but you get the idea. So here's a much better drawing that Desmos does for us. You can see just simply by putting the equation in. So here's the back point, which we said was negative 2, 2, which it shows there. And then here's our lattice segment, 1 unit over, and you can see that thing is 4 units long. So again, the only difference between these and the other kind of parabolas is it just has to be shifted to start at that new vertex instead of the origin. Okay, let's look at this example. Now in this one, the square is on the x term. So since it's on this x term, it's going to either open up or down. But because this, in this case, it's a negative 8, so the number is negative, this one's going to be a parabola that opens down. So this parabola will go down. So let's talk about some parts of it. So what's the vertex? So the vertex, just like the last one, we'll look at the opposite of what's in the x. So the opposite of what's the x, it's a 4, so the opposite would be negative 4. And the y, it is a 7, so the opposite would be negative 7. So this has a vertex of negative 4, negative 7, which is down here. And it's also going to open down. And the reason it opens down is, again, this negative 8. because we're thinking 4 times what A gives us -8. Well, that A would have to be -2. So we're going down 2, so the focus is down here. Okay? So our vertex and our focus. The lattice length in this case, it's the absolute value of -8 because we don't really care about the negative sign for length, so it's 8. So it's going to be 4 on each side of that focus, so here and here. So it's going to open something like this. So again, nothing really very difficult about these. I found the vertex by taking the opposites. I figured out what A was because it's 4A, so I'm thinking 4 times what gives us that number. And then I just used the lattice to kind of see how wide it is. If we look at our Desmos graph, right down here, here is our vertex, -4, -7. The focus would be a couple units down, so that would be here. And you can see this would measure 8. But the big thing is knowing where the vertex is, knowing this lattice length. I mean, the rest you really can get from the graph, and with the Desmos calculator, it doesn't make it very difficult to see that. Okay, let's look at our last problem. We want to try to find the equation of a parabola with a vertex of 3, -4. So we have this one has some information. So we know 3, -4 is our vertex. And a focus of 0, -4, which is over here. So we know this parabola is going to open to the left because it has to open that way. So since it opens to the left, I know the square term is going to be on the y. I don't know what else will be there. There'll be something else because it does have a vertex. So it's going to be y something squared, x something, and then 4a will be in front of the x. Now my vertex is 3, -4. So I'll just take those to be the opposite. So x minus 3 and y plus 4, because minus -4 is obviously plus 4. We only have to now find the a, which is the distance from the vertex to the focus. So the distance here between the vertex and the focus is just 3, but it's -3 because it's going to the left. So this a value is -3. So 4 times -3 is -12. X minus 3, which is the x part of the vertex. And y plus 4 squared, which is the y part of the vertex. So this parabola is guaranteed to have a vertex of 3, -4 and a focus of 0, -4. I graphed it down here, and you can see it does have the proper vertex. It's at the edge there. Focus really isn't part of the graph, so it's hard to determine if that's true or not. I could always count from this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this Latus Rectum length is 12, and we did say it was supposed to be 12 because it's -12, but we said the length is always the absolute value of that. So that's really it for section 3 on parabolas. Obviously a section made much easier with our Desmos graphing calculator. So go ahead and give this a shot, and if you have any questions, please let us know.